Today, on how it's made. Graphite pencil leads. Clarinets. And special effects. Despite the name, the lead core of a pencil isn't actually made of lead. It's made primarily of graphite, a form of carbon that's very abundant in the Earth's crust. To produce pencil leads, they combine graphite powder with water and clay. The higher the ratio of clay, the harder the lead. Quality graphite pencil leads don't break easily and glide smoothly on the page. Graphite is mined from both open-pit mines and shaft mines, like this one in Germany. Miners use hammer drills to bore holes for explosives. The chunks of ore must contain at least 30% graphite to make the area financially viable for mining. At the surface, a crusher breaks the ore into small pieces. Then, adding water and oil, they pulverize it in a rotating mill. This ore soup then flows into a system that separates the graphite from the impurities. The graphite particles cling to the air bubbles and float to the surface. Skimmers send this layer of graphite foam back into the mill. 5 cycles later, the graphite concentration is 96%. However, it's soaking wet, so it has to go into a dryer. After spinning around at 300 degrees Celsius for about 30 seconds, the graphite becomes a completely dry, fine powder. Mined and processed, it's ready to be shipped to the pencil factory. To make pencil leads, the factory combines graphite powder with clay and water. During the 35-minute mixing cycle, it's critical to control the blending speed, pressure, temperature, and moisture level. This produces homogeneous granules, the key to ensuring that all the leads will be uniform in quality. The granules go into a hydraulic press, which shapes them into a cylindrical block. Workers then wrap the block in film to prevent drying out and set it aside for a week to cure. They load each cured block into a hydraulic press, which pushes it through a forming die, producing one long continuous lead. Different dies give different sized leads. The next machine then cuts the continuous lead into pencil lengths. The leads are the right thickness and length, but they're soft and pliable because they still contain water from the mixing process. Workers load the leads into a rotary dryer at 160 degrees Celsius. 12 hours later, the leads exit the dryer straight, but not quite strong enough. So next, they go into a kiln for 10 hours at 1000 degrees Celsius. This firing transforms the clay that's mixed with the graphite, strengthening the leads to their final hardness. Finally, a 12-hour bath in a mixture of high-quality waxes. The waxes fill the pores in the leads, leaving them with a surface that glides smoothly across paper. Throughout the production process, The factory puts samples through quality control testing to check hardness, break resistance, diameter, and of course, writing quality. This company produces 3 different qualities of graphite leads in 16 different hardness levels, plus a full array of colored leads made similarly, but with pigment powders and waxes rather than graphite. When the clarinetist blows into the instrument, a reed in the mouthpiece vibrates, creating sound. To turn that basic sound into different notes, the player manipulates the length of the air column inside the instrument by opening and closing different tone holes. The standard clarinet has 24 tone holes. The musician covers some with his fingers, the rest by pressing keys. Those keys are made of nickel silver, or sometimes brass. They inject hot wax into a plaster mold of a specific key. Then, using hot wax, they attach several models of the same key onto a stem. They put this tree, as it's called, into a cylinder. Then into a mold-making machine, which fills the space around the tree with a silica-based ceramic material. When the ceramic hardens, they melt out the wax through an exit hole at the bottom, leaving behind a tree-shaped cavity. Now they transfer the mold to a casting machine and load nickel silver into its miniature furnace. The metal melts and fills the entire cavity. To cool and solidify the casting, they submerge the mold in lukewarm water. The metal contracts as its temperature drops, loosening from the mold. They extract the tree and remove the keys. Then they grind off the little stub left on each key. Next, the keys go into a tumbler filled with synthetic stones. The stones polish the keys, preparing their surface for silver plating. Silver doesn't adhere directly to nickel silver, so they plate the keys in copper first. For each layer, they submerge the keys in a chemical solution, then apply a negative electric charge while running a positive charge to pieces of the plating metal. Like a magnet, this draws particles of the plating metal onto the keys, forming a thin overall coat. A clarinet's 2-part body is typically made of wood, or, like these, plastic resin. A computer-guided drill bores 24 tone holes and 40 smaller holes for the posts which support the key mechanisms. A sonic welding machine presses each post into its respective hole, while zapping it with a high-frequency sound wave to melt the plastic around the base. This anchors the post securely. The next machine reams a hole through the head of each post for the rods that operate the keys. They wrap natural cork around the connecting ends of the body, then illuminate the interior for a quality control inspection. It's time for the final assembly. They lubricate all the moving parts, then install the 17 keys onto their mechanisms. Each key has a foam pad to prevent air from leaking out when the hole's covered. They use a strip of foil to test whether the seal is tight enough. With both body sections of the instrument finished, a musician assembles them and checks that each and every key moves fluidly. Then, after attaching the bell and the mouthpiece, she conducts a sound quality test. performing a set of musical exercises. The clarinet now goes to the packing department, where the packager gently removes fingerprints, lint, and lubricant residue, then lays the instrument parts in a velvet-lined case. It's a fitting finale to the making of an instrument that looks as good as it sounds. Special effects in animated films breathe life into characters and scenes that are completely imaginary. It usually takes a mix of different effects to give the fantasy a realistic texture. From miniature scale models to computer-generated imagery, it's all about the big picture. "3D animation and photographic tricks make this miniature village loom large on the big screen. It all starts at the drawing board. An artist sketches the various components of the fantasy village. Once he gets it down on paper, the rest of the crew can build it. Using one of the sketches as a reference, a sculptor carves foam into sections of a roof, and he glues the pieces together. This foam roof will then be used to make a mold. The mold maker builds a box around the roof, which is now gray-colored due to the application of a non-stick substance. He pours liquid silicone rubber onto the foam roof in the box. After 12 hours, they pull apart the box and remove the foam to reveal the mold. This mold will be used to cast multiple roof parts for the mini film set. They mix a 2-part urethane solution and pour it into the mold. A chemical reaction causes the urethane to solidify, and as it does, it takes the shape of the mold with all the details. After half an hour, he extracts the cured urethane from the mold. It's a perfect copy of the original roof carving. They mold various roofs for visual interest. The crew then paints all the molded parts of the mini village set in colors that are true to life. The palette has been selected beforehand, but if it doesn't look right to the eye, adjustments can be made. For larger scale structures, a technician arranges reflective dots in a grid pattern. These dots serve as reference points to laser scan the image of the house into a computer. The technician transfers the image a section at a time. Once the image has been loaded into the computer, animators can really play around with it. They can insert digital characters or impose a digital image over a filmed one to cast a shadow. Meanwhile, another member of the crew plants molded trees onto hills of plastic and shapes the landscape of the set. The trees and vegetation are very small scale because the landscape will be in the background. In the world of digital animation, clumps of moss can mimic shrubs, and a hot glue gun is an indispensable tool. Once buildings have been inserted in the set, the crew brings up the lights and checks the effect. They add props and sometimes take others away to improve the look of each scene. Technicians tweak the lighting, which can add visual depth and credibility to any scene, but it's even more critical with a small-scale vista. Little rectangular mirrors attached to the lights allow for minute adjustments. The director of photography operates the camera remotely. Adjustments to the shot's frame or depth of field can trick the eye and make miniatures seem much larger. The computer records the camera movements so they can be repeated at any time. Later, water will be digitally added to this riverbed. Coming up next, animated characters enter the scene with the help of computer-generated tricks. Today, virtual beings are a Hollywood phenomenon. Computer effects have rocketed 3D animated characters into superstardom. But even for digital creatures, fame doesn't come easy. It takes years of work and a large crew of skilled professionals to make them look good on the big screen. It all starts with a good old-fashioned sketch pad. Once the character is defined on paper, the artist sculpts him with clay. Then the high-tech wizardry begins as they laser scan the 3D character from all angles and load the image into the computer. Once he's been captured, the computer artist wraps the character in a digital wire frame. He manipulates the wire mesh to make the character move and breathe. After he creates a dozen or more facial expressions, this machine makes hard copies of those many faces. It repeatedly deposits layers of plastic to build up a physical version of the image. They insert eyes in the sockets, then give these washed-out plastic faces some color. An artist paints each one of the faces along the same lines. Continuity is critical because the faces will be filmed and the images edited together to create the illusion of movement. It's a traditional animation technique called stop motion, and these plastic models are called puppets. Next, a seamstress builds a suit of clothes for one of the puppets. He has to look great, because he'll be used to promote the character to merchandisers who might market him as a toy. They scan the fabric and wrap it around the digital character to give him the same outfit. Then add creases for a more realistic texture. The crew lights the mini set for one of the character's big scenes and plans the camera moves. It's a kind of dress rehearsal. One of the puppets acts as a stand-in for the animated character. They move him around in a process called rough placement. It's a critical step which ensures that everyone is in sync: cinematographers, lighting artists, and animators. Seeing the puppet in the room will help animators place his digital counterpart in the various visuals. They literally cover all the angles and leave nothing to chance. Now the physical merges with the virtual in a special effects trick called human motion capture. A man walks around in a special suit covered with reflective dots. The computer recognizes the dots to transfer the man's movements to a version of the digital character instantaneously. The computer artist uses those captured movements to manipulate the character and insert him into the scene. The effect is one of a digital character who moves just like a human being. They layer digitized images of the set and blend them seamlessly into a single image. This digital layering is called compositing. It allows animators to accurately place the character in the scene. The blend of high-tech special effects with traditional animation techniques gives the best of both worlds. Combined, all these special effects tricks can generate 3D characters with star quality. They are virtual puppets, and the animators are the puppeteers. And on the big screen, the fantasy has never looked so real. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howithasmade.net.